All right, honors geometry. Here we come with the 8-6 law of cosines now. So again, counterpart to the law of sines. So at the very top here, when are we to use the law of cosines? Well, these two situations, side angle side or side side side. So remember, we're focusing on non-right triangles and trigonometry, right? So side angle side, typically you'd be looking for that third side. And with side side side, you'd eventually find an angle. So you'd have to use probably the inverse cosine, right? Because it's the law of cosines. So here is the concept, law of cosines. There are three forms because it all depends on what side you're focused on, what angle. The most important part of this is to remember that the side you have by itself on the left is opposite of the angle you use in the cosine. So be aware of that, okay? But notice it looks kind of like Pythagorean theorem, right? C squared equals a squared plus b squared. But then there's this extra part, like this minus 2ab cosine of c, okay? So what I'm going to do is I'm going to prove this specific formula on the next slide, but I could do it the same way for all three, all right? Okay, so very similar to the law of sines, I will draw this height down. It creates two right triangles. I'm going to call this h. Now, the other part of this is we're going to introduce another variable x. We're going to let this length be x. So then this length would be c minus x because this c goes all the way across. So if I let this piece be x, then this piece is c minus x. And what I'm going to do is I'm going to do three things. I'm going to first do a cosine equation using this triangle here. So cosine of A, angle A, is going to equal my adjacent side, x, over my hypotenuse, b. And I'm going to solve this for x by multiplying both sides by b, and I get b cosine of A equals x. So I'm going to substitute that in later. The second formula I'm going to use is I'm going to do Pythagorean theorem with this triangle on the left. So that would be x squared plus h squared equals b squared. And I think you're going to see this somewhere else, x squared plus h squared. And then the final thing I'm going to do is I'm going to use this triangle, and I'm also going to do Pythagorean theorem. So it's going to be c minus x squared plus h squared equals a squared. Now, c minus x squared is c minus x times c minus x. So I need to multiply that out. So I get c squared minus cx minus cx plus x squared. So I get c squared minus 2 cx's plus x squared. Now I'm going to bring down the plus h squared and bring down the equals a squared. And now we're going to take this formula and do some substitutions. I see an x right here. That's the same x here. So this is going to go in place of that x. And I also see my x squared plus h squared here. So remember, it was up here. B squared is going to go in place of that. Okay, so I'm looking at c squared minus 2c in place of x. I'm going to put b cosine of a. In place of the plus x squared h squared, I'm going to put plus b squared, and that'll equal a squared. And now I'll just reorganize this left side. So I'll put the b squared first, I'll put the c squared second, and then I'll rearrange this into minus 2bc cosine of a, and that's going to equal the right side of a squared. And this is exactly the formula you see with the a squared on the right side instead of the left side. And this is how the law of cosines was built. So again, it's rather longer than the law of sines. It can be very simple if you're looking for side A, but then it can also be very difficult if you're looking for the angle A. So we'll make sure to do examples of both on this video. Okay, so here comes the first example. Actually, I decided I will make another video to do the examples. So this is the end of the first video. Second video is coming up.